Hello everyone and welcome to Recon's horizontal well demo. Today I'm going to show you how Recon can use up-to-date log information to help create a more accurate geological interpretation. Now if you haven't seen Recon before, I'll introduce you to the three windows. On the left hand side we have our 3D view. On the top right we have our map view or base map, and on the bottom right we have our cross-section view. Now a brief history about the data that we're dealing with. This was an offshore play dealing with unconsolidated sandstones. Now if we take a little closer look, we have undulating wells here displaying two log curves. On the left hand side we have our gamma ray log curve, and on the right hand side we have our resistivity log curve. Now these red portions that we see along the well bore represent penetration of the oil reservoir. So going forward we're going to want to see as much red as possible. The first well that was drilled in the project is this 14H well. Now you can see they had some success initially finding the reservoir, but unfortunately lost contact and were unable to regain access to the reservoir. The second well drilled was this 15H well. Despite having more success initially, they were able to go a little further along in the pay zone. Unfortunately they again lost contact and were unable to regain control of the bit into the pay zone for the latter portion of this wellbore. Now at this point in time, Recon was brought in to be part of the consulting process. The first thing we did was recommend that they stop drilling so we can analyze the data that they have and recreate a more accurate drilling plan. But unfortunately, due to external pressures, they began our 10H well that we see here. And again, limited success in the beginning, but they soon realized that history was about to repeat itself and promptly abandoned the well. Now what Recon noticed right away is that the data that they were using was of really poor quality. They were actually using very poor seismic quality data, which is why you don't see it in the backdrop in the 3D view or in our cross-section view here. So making their horizon picks and tying it to the well data proved very difficult. Now what we actually see here is the original top surface pick. Now right away you'll notice that it actually lies below our reservoir, so we know something's up right off the bat. So what Recon did, the consulting team, they made new top picks that we see here in pink, using the log information that we had available, and created a new surface. So using Recon's conformability option, we actually took that seismic surface that we see in the backdrop, that top horizon, and we snapped it to those new top picks and created a much more accurate interpretation of that top surface. So taking a look at it in 3D view, we'll see that right away it looks like we have a much more reasonable interpretation of that top surface. Now this same process was done for the base surface. I'll turn on that base surface just so we can actually see our well bores and our log information throughout the rest of this demo. And there we can see again it looks like a more reasonable representation of our data. Now what Recon recommended is we actually use that log information that we're receiving right from the rig and use it to help steer the bit and understand what trajectory should be taken going forward throughout the drilling plan. So what Recon's able to do is actually take that log information and use it as it comes in. Now here I've stitched a few of these steps together just for the sake of the demo, but we see the data coming in as it comes in from the rig, and we're able to see exactly what the drilling team is doing. Now where this information becomes the most useful and practical is in our cross section. So looking at the cross section on the bottom right hand side here, we see four surfaces. Our green represents our original base pick. The red represents our original top surface pick. The gray represents our base surface pick, which we see in the 3D view right now. And the purple pink-ish line that we see in the top represents our top surface pick. So looking at that first bit of log information coming from the rig, we see right away that it looks like we may have gone too far and drilled past the reservoir. So what we can do is use Recon's quick pick option and simply recreate that pick. And as soon as I make that pick, you'll notice right away all my interpretation updates. Now on the map view, we're displaying an isopack between that top and base surface. So you see it updates to reflect our new pick. And of course the base surface on the 3D view is now displaying our new pick. Now we can actually click on this pick to see it in well view and get an even more accurate and detailed representation of the log data. Again, log curve information. We have resistivity on the right hand side and our gamma on the left hand side. So we can see that it looks like my pick was made slightly premature. We'll move it down just to make a more accurate representation of where the actual base should reside. And again, as soon as I move that, we see our update on the map view and 3D view. So right away, we recommended that they increase the trajectory of the bit. Using Recon's measurement tool, we recommended that they increase the bit in between 0.7 and 1.3 degrees to get back into the reservoir. We can see that angle on the bottom right hand side of the cross-section window. So stitching through the next piece of data, we can see that the drilling team responded appropriately and we're able to get back into the reservoir. Again, I can make a quick pick and adjust my interpretation to reflect this new data that we have coming in. Now this process was followed throughout the drilling plan as Recon continued to advise the drilling team what needed to be done as far as steering the bit to maintain that reservoir. Now this, as you can see, we're getting a lot more success until unfortunately towards the end we had difficulty steering the bit, and that is where we decided to end the well. So where we really see the success of this plan is this next well that we drilled, our 11H well. Looking at it actually in the 3D view here, we'll see that it does a much better job of maintaining the pay zone as we go through it. Now this well was actually more productive than the 3 previous wells combined, and that's both in initial and cumulative production. So looking at the 3D view, we do see a lot more red, higher resistivity values. Looking at the cross-section view, we simply select our 11H well. We really see the success and improvement that we were able to make using Recon's new way of using that log information as it came in. Now what we decided to do next was create an attribute map based on these resistivity values. Since we believed that was such a good indicator of the actual production, we wanted to create an attribute map that would kind of help indicate what the resistivity is doing throughout this area. So going to the surfaces, I'm now going to select zone average instead of elevation. I'm going to actually use my resistivity curve only, which is my WLLD. I'm using true vertical thickness, which is typical for volumetric calculations. And I'm actually going to make calculations in between the top and base surface. So we're doing a single zone average here. And I'm going to choose to display it on the base, just so we can still, again, see those well bores and that log information. So turning that on, we now see our resistivity and how it changes throughout our reservoir and our zone of interest between the top and bottom. Now since we use single zone average, it's actually creating a calculation whenever that well enters and exits the zone of interest. So whenever it leaves our zone, it's going to recalculate a new average. So for example here, we see, especially in the portions, these last 2 wells, when we did do a very good job of maintaining the pay zone, we're getting an average done over a long stretch of the well bore. So here we see that it exits our zone. Looking at it from underneath there, we see that it actually left the zone and then it re-enters, and now it's creating a new average calculation along the well bore for this portion, just like it created an average for this long portion here. So we have a good approximation of the resistivity and what it's doing along the well bore and in this 3-dimensional space. But it'd be a little bit more practical if we're able to see it in smaller increments. So what we can actually do is instead of using single zone average, we can go along the measured depth of the well. And in this case, we're going to go every 50 meters down the well bore and calculate an average based on that. So activating that, we see we have a much more detailed and high resolution of what the resistivity is actually doing. Taking a look at the range of values, we can see what it's actually doing throughout the reservoir and what our range is. Now we can actually click on any one of these values to see what that average is during that portion, during that 50 meter portion along the well bore. So you can see here all our information for that specific spot. Now if we zoom out, we see that we do have looks like some outlier data outside of our well control, so we can simply go to grid filters. We're going to select our base surface because that's what we're displaying right now. It automatically calculates the appropriate range, and now it gives us a much better, neater map of what the resistivity is doing. So as you can see quickly, Recon can create this attribute map that can not only be a great indicator of success, and in some cases lack of success, as we saw earlier on in our drilling, but it also can be an indicator for or predictor for future progress and the appropriate places to drill. Now that concludes my presentation on Recon's horizontal well capabilities, including using up-to-date log information to help creating a more accurate geological interpretation. I hope you found value in the presentation, and thank you for your time.